have to say, seeing theology and tensor calculus in the exact same bibliography is, well, it's a first for me.
Yeah, it is definitely not your standard self-help setup. Welcome to today's deep dive, by the way.
Right. Welcome, everyone. So usually when we talk about kindness or paying it forward to, people in your network, it's very soft, very warm and fuzzy.
Exactly.
But today we are looking at the Omega Calculus by Timothy J. Dillon, and there is absolutely nothing soft about this text.
No, not at all.
He's basically claiming that this warm feeling of kindness is actually a hard mathematical operator, like something that physically alters the geometry of our social networks.
And that makes total sense when you look at Dillon's background. I mean, he isn't a psychologist. He isn't a sociologist.
Right.
He comes from the world of high-frequency data, predictive analytics, algorithmic sports betting with places like you call the Play Inc.
Which is a world where feelings are total liabilities. Like in sports betting, you do not care if a player is nice. You care about vectors and force.
And outcome probabilities, yeah.
Sure.
He also spent time at big tech, Microsoft, Nike. So he's bringing this very geometry-first, physics-based approach to human behavior.
Our mission for this deep dive is to basically map out how he turns moral virtues into rigorous tensor mechanics. He calls it social physics.
Right. He's essentially asking, what is the statistical probability that an act of mercy yields a return on investment for the network? Which sounds so cold.
It does. So let's look at the variables he's using. He introduces this concept of moral curvature, which, reading through it, it sounded a lot like electrical resistance to me.
That's a really great way to visualize it. In Dillon's model, human behavior propagates like light waves bending around gravity.
Okay.
So high curvature represents tension or friction in a relationship. It's the gravity that drags everything down, whereas low curvature is a straight line. It's ease, it's speed, it's trust.
And in this whole geometric universe, you have two forces fighting for control, right? Syntropy and dispersion.
Yes. Syntropy is the force pulling systems toward order and connection. Dispersion is the entropic force, the noise that drives fragmentation and tears networks apart.
Which brings us to Theorem 22. I just love that he gave it a number like it's a legal statute.
It's his pay-it-forward theorem.
Right, but treated as a literal law of physics.
He defines kindness not as a moral good, but as a curvature-reducing operator.
Meaning,
when you are kind to someone, you are physically shortening the geodesic distance between two nodes in the network. You are reducing relational friction.
So if I buy the person behind me in line of coffee, I'm not just being nice. I'm lowering the activation threshold for them to do the same thing.
You're lowering the speed bump. Because you reduce the curvature, it is mathematically easier for the next person to be kind. And then the next.
So the behavior cascades exponentially.
Exactly, because the path of least resistance has changed.
Okay, but I spot a flaw in the math here. If I lower the activation threshold for everyone, am I not just making myself a target? Like, if I drop my defenses, bad actors can just walk right in and take advantage of you.
And that is exactly where Dillon shifts from hippie to engineer. This is the part of the text that really stuck out to me. The M1 moral filter.
Ah, right. This is his argument against blind altruism.
Precisely. Because in physics, vectors have magnitude and direction. Dillon argues kindness is a vector. You can't just spray it everywhere and hope for the best.
You have to calculate the syntropic potential of the recipient, right?
Right.
Which is just a very fancy way of asking, is this person going to pass the signal forward, or are they a black hole?
He actually uses that exact terminology. He warns about this concept of entropic inversion.
Where you pour resources into a parasitic node.
Yes. If you pour kindness and trust into a highly adversarial person, you aren't fixing the network. You are feeding the dispersion. You're giving energy to the exact thing tearing the network apart.
That's a really heavy concept. It implies that withholding kindness can actually be the mathematically correct move.
It's system hygiene. You have to isolate those friction points to protect the overall geometry.
So where does this geometry actually lead? If we use the M1 filter, we block the parasites, we maximize the syntropy. What is the end game of all this?
This is where the omega point attractor comes in.
From the theology side of the bibliography.
Exactly. He draws this from Pierre Teilhard de Chardin, a philosopher who believed the universe is evolving toward a state of maximum consciousness and unity. In Dillon's Calculus, the omega point is that state of absolute stability.
So kindness isn't the goal itself, it's the ignition mechanism to reach that stability.
It really recontextualizes your whole day. You aren't just being nice to the barista. You are manually adjusting the friction coefficient of your local network to prevent a system crash.
It's literal system maintenance. It
Yeah.
definitely changes how I'm going to look at my commute home today. And it leaves all of you with a big question to chew on. Think about your daily interactions as the actual mathematical variables they might be. Are you acting as a source of syntropy in your own network's geometry? Or are you the one increasing the curvature? Thanks for diving in with us.